Okay, so this is our first set of notes on the cross product. Okay, so the cross product is another way of doing vector-to-vector multiplication. So let's say I start off with two vectors. And in the cross product, we always visualize these in R3, okay? So this is something that is specifically defined as R3. So we're going to represent another vector called AB, which is a very interesting multiplication of the components here. So we take A2 times B3 minus A3 times B2, A1 times B3. That's not correct. Let's fix that. A3 times B1 minus A1 times B3. And then finally A1 times B2 minus A2 times B1. Okay, so this is a little bit of a complicated formula, and we'll look eventually at how to make that a little bit simpler. But if we have that, we call A cross B, which is also an element of R3, the cross product of A and B. Okay, a little simple way to kind of make sense of this is that if I make this I, J, K and put A1, A2, A3, B1, B2, B3, and then put again I, A1, B1, J, B, A2, B2. Okay, so what I've done here is I've built a kind of a framework here, and then I repeated the first two columns. And then what I'm going to do is I'm going to make a couple of moves here. I'm going to go downward. 1, 2, 3. And if I do that, I get A2B3I plus A3B1J plus A1B2K. Okay, now I'm going to go the opposite direction. I'm going to go up. So this is going to give me minus A2B1K minus this one is A3B2I, and then go up here one more time, minus A1B3J. Now, if you take a look here, that's going to mean that I have A2B3 minus A3B2I plus A3B1 minus A1B3J plus A1B2 minus A2B1K. So this gives me the vector A2B3 minus A3B2, comma, A3B1 minus A1B3, comma, A1B2 minus A2B1, which is exactly A cross B. So using this idea of going down 3 times and then up 3 times to give you the positives and the negatives is a strategy you can use to calculate a cross. We can get a quick property from this, okay, without doing too much work. Let's let A be an element of R3, and our property is then A cross A has to be the 0 vector. So let's take a look. I'm going to prove that real quick. If I take A cross A, this is going to give me A2, A3 minus A3, A2, A3, A1 minus A1, A3, A1, A2 minus A2, A1. And if you look carefully, that's the vector 0, 0, 0, which is the 0 vector. So what we've proven there is that any vector times itself gives me this mysterious 0 vector. Okay, so we have a formula here for calculating a cross product. We have a bit of a framework that we can use to help us with that. And we have a quick property that we can use that any vector times itself is going to give me the 0 vector.